Okay, so let's look at example 3 on the 11.2 notes. It's on the second page of the 11.2 notes. So this has to do with perimeter now. So for example 3, we're told that each of the figures has an area of 4 square centimeters. So each one of these, this is a square centimeter here, and this is a square centimeter, this is a square centimeter, and this is a square centimeter. And we're asked to find the perimeter. So perimeter means what is the distance around the entire shape. Okay, so let's look at one of these squares. So if one of these squares are 1 square centimeter, then that means in order to get 1 square centimeter, it means that the sides of the figure, so whatever this side is, and whatever this side is, when we multiply them together, we must get 1. And the only option for that, so some number, well, and actually we don't necessarily know that they are the same number. Let me get that back here. Technically, we could say this is x and y. So x times y equals 1 square centimeter. The only option for that is 1. So 1 times 1 gives us 1. So that means that the distance, or the length, of both sides, we'll just stay in black here, is 1 and 1. So all of these are 1. So 1 times 1 is 1 square centimeter. So that means that if we want to find the perimeter, we know the distance of here to here is 1, and here is 1, and here is 1, and here is 1. So we can just add all of those up, and that gives us the perimeter. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter is going to be 8. And if the area is in square centimeters, then each of the sides is just regular centimeters. So the units for perimeter are in centimeters. Similarly, with this one, we know that this is 1, and we know this is 1, and 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 10 centimeters. And it's interesting to see they both have the same area, yet the perimeters are different just because of the arrangement of the shapes, and sometimes that ends up happening. In example 4, we're given, so now we're starting areas of polygons, so we're entering in a new part of the notes. So I'm just going to highlight that here. So we're going to start by finding the area of a rectangle. So if you're making a formula sheet, this would be a good thing to put on the formula sheet. So the area of a rectangle is length times width, or LW. And so if we go down to this figure in example 4, now I think it's important to mention, so if I asked you, what is the length? A lot of times people would say, oh, it's 55. It really doesn't matter. So the definition of length doesn't mean that it's horizontal. We could say that 55 is the width and 25 is the length. It really doesn't matter which one is which, but I'm just going to start by writing down the formula. So area of a rectangle equals length times width. I think this is a good practice to always just get in habit of doing, and then multiply the numbers together. So 25 times 55, and we end up getting 1375. Now what's really important is you always want to give the units, especially looking forward to the next test. You're going to want to put your units with all of your answers for the test. So let's practice here. So if the sides are millimeters, so if this is millimeters and this is millimeters, when we multiply those together, we get square millimeters, which is what we want for area, square units. Now, if I scroll down, I'm just going to scroll down to the next page here. So example 5, the area of a rectangle is 12 square inches, and the width is 3 inches. What is the length? So anytime we're told about a figure and we're told what we're looking at, so in this case area, I'm going to write down the formula. So area of a rectangle is length times width, and I'm going to plug in what I know. So the area is 12 square inches. Okay, we're finding length, so I don't know what that is, and the width we know is 3. So I'm even going to put the inches in there. So we've got 12 inches squared equals the length times 3 inches. Now if I want to get length by itself, I'm going to divide both sides by 3 inches so that those go away. Okay, 12 divided by 3 is 4. inches squared divided by inches is just inches, and that's equal to the length. Now, I don't think it's necessary for you to always put the units in when you're plugging into the formula, but I thought it's nice to see it done at least once or twice so that you can see that they actually divide and you end up getting the units that you would expect for length. So we start with, you know, square inches for area, and we end up with just regular inches for length, which is what we want. And lastly, let's do example 6. So the area of a square, so I'm going to draw a square. The area of a square is 25 square centimeters. Now notice up above, like on the previous page, we have an area formula for a rectangle. Remember that a square is a rectangle, so we can use the same formula, length times width. Okay, so we know that the area of the square is 25. How long is one side? Now notice they didn't mention anything about length or width here, and that's because with a square, all the sides are the exact same measurement. So really, we don't need two separate variables here. We could say, you know, maybe we'll say all of them are the width because they're the same number. So we could say 25 equals width times width, or 25 equals width squared. So ask yourself what number times itself equals 25, and you might be able to say, well, that's 5. Or if you can't think of that right away, you could look at it algebraically at this part and say, okay, well, how do you undo a square? Well, you take the square root of both sides. So W, the width, is equal to 5. Now, some of you have taken algebra before. You might say, oh, well, the square root of 25 is plus or minus 5. In this case, it doesn't apply because we're dealing with the length of a side. So we don't need to write -5 since that wouldn't make sense. So the answer is 5, and then we're going to write centimeters in there to use our units.